Space is like a dark ocean filled with mysteries. The voids between stars, the infinite motion of galaxies, and the mysterious traces on the surface of the moon have always deeply affected humanity. Despite harboring many secrets waiting to be discovered in the depths of space, NASA's Artemis program is a bold step towards unveiling the curtain of this mysterious universe. The Artemis program is a comprehensive space exploration initiative created by NASA in the 21st century to achieve the goal of human missions to the moon. Restarting crewed lunar missions and sending astronauts to the lunar surface, as well as establishing sustainable lunar colonization, are the aims of this program. Named after the ancient Greek goddess of the moon, Artemis, the Artemis program is considered a significant milestone in humanity's space exploration. The primary goal of the program is to return humans to the moon by 2025 with a crewed mission, thereby re-establishing human presence in space. The vision of the Artemis program extends beyond merely sending humans to the moon. It also aims to provide long-term presence on the moon and establish a sustainable habitat in space. This program presents an opportunity for the development of new technologies and expanding the boundaries of human presence in space. The Artemis program represents an exciting step towards the future of humanity's space exploration. Its success could enable humanity to venture deeper into space and perhaps, one day, send crewed missions to Mars and beyond. The return of humanity to the moon represents one of the most significant milestones in space exploration. The importance of this return stems from a variety of factors and offers numerous opportunities and potentials for humanity. Firstly, the return to the moon by humans is a testament to technological and scientific progress. The moon, which has long been seen as an unreachable goal for humans, has become accessible again as a result of technological advancements and human curiosity. The return to the moon offers an opportunity for humanity to push technological boundaries and expand its limits. Secondly, the return to the moon is a critical step in increasing the sustainability and depth of understanding of space exploration. The moon, located near our planet and more accessible compared to other objects in space, provides a tangible target. Thorough exploration of the lunar surface can provide scientists with significant insights into the evolution of the solar system and the history of Earth. Thirdly, the return to the moon symbolizes humanity's progress towards establishing sustainable existence in space. Discovering and utilizing resources on the moon can lay the foundation for long-term presence in space. This scenario can serve as preparation and a model for future human space explorations. To achieve the goal of returning to the moon, the Artemis program is undergoing a multifaceted preparation process. This preparation includes the development of new technologies, astronaut training, design of rockets and spacecraft, and establishing the necessary infrastructure for life in space. NASA and other space agencies are developing spacecraft and rockets specifically designed for the return to the moon. These vehicles must have the capacity to transport people to the lunar surface and safely return them. Astronauts undergo specialized training for lunar missions and go through simulations and practical exercises to adapt to living conditions in space. Infrastructure and technologies necessary for human habitation on the lunar surface are also being developed. These include habitats, oxygen production systems, water purification systems, and energy production systems. The envisioned missions of the Artemis program include restarting human missions to the moon and conducting long-term exploration and research activities on the lunar surface. These missions will be carried out using spacecraft, modules, and other equipment designed to enable humanity's return to the moon. Artemis 1 is the name of a space mission planned by NASA under the Artemis program. The Artemis 1 mission is not a crewed mission but rather a preparatory step towards the goal of transporting humans to the moon and is designed as part of the program. It is planned to test the capabilities of transporting humans to the moon, evaluate the performance of spacecraft and systems, and develop the necessary technology for human missions to the moon. This mission is an important step in testing the spacecraft and subsystems required for the return to the moon. The Artemis 1 mission will be carried out using NASA's Orion spacecraft. The Orion spacecraft is designed to transport astronauts on deep space missions. It was successfully launched from Kennedy Space Center on November 16, 2022. The main objectives of the Artemis 1 mission are evaluating and testing the performance of spacecraft and systems, observing how the spacecraft responds to solar radiation, heat changes, and other space conditions, testing the processes of launching into lunar orbit and returning to Earth, and observing and improving the capability to transport humans to the Moon are the main objectives of Artemis 1 mission. The Artemis 1 mission constitutes a significant part of the preparation process for human missions to the Moon within the Artemis program. Artemis 2, on the other hand, is a space mission planned by NASA as part of the Artemis program and will be the second human mission to the Moon. Designed as part of the Artemis program, Artemis 2 is set to begin for the first time in 2023. Its main goal is to test the hardware and technology necessary to transport humans to and from the Moon. This mission serves as preparation for crewed flights to the Moon. One notable feature of Artemis 2 is that it will orbit the Earth before reaching the Moon. During this orbit, astronauts and the team will test the spacecraft's performance, check the equipment, and prepare for the rest of the mission. Artemis 2 will not land on the lunar surface, but the spacecraft will have the opportunity to approach the Moon to test specific scenarios. This mission represents a crucial step in verifying the fundamental steps of crewed lunar missions and preparing for long-term objectives. The success of Artemis 2 will play a critical role in the progress of the Artemis program and guide the planning of subsequent steps towards crewed lunar missions. This mission will provide a significant opportunity to test the reliability and performance of spacecraft and equipment. Artemis 2 is expected to mark the beginning of a new era in crewed space exploration. Artemis 3, planned as part of the Artemis program, represents the third stage of NASA's goal to send humans to the Moon. Artemis 3 aims to achieve a crewed landing on the Moon and conduct long-term exploration missions on its surface. Considered a critical step forward in the progress of the Artemis program, Artemis 3 will see astronauts land on the lunar surface to conduct in-depth exploration and scientific research. Tasks during Artemis May 3 include better understanding the Moon's geological structure, identifying resources on its surface, and testing habitat and life support systems. Building upon the successes of previous missions, Artemis 3 aims to achieve a successful human landing on the lunar surface, ensure astronauts can work safely, and then return to Earth. This mission aims to assess the sustainability of human presence in space and evaluate the potential for establishing long-term human presence on the Moon. Artemis 3 will also provide a significant opportunity to understand the technical, physiological, and psychological challenges that humans may encounter while working on the lunar surface. This information could play a critical role in planning future long-term lunar missions and preparing for crewed Mars missions. The planning and preparation of Artemis 3 represent a significant milestone in the progress of the Artemis program and symbolize humanity's advancement in the field of space exploration. Gateway, a central component of NASA's Artemis program, is a space station project. This small space station, to be placed in lunar orbit, will serve as a waypoint for human missions to the lunar surface and other deep space destinations. Gateway will facilitate safer, more efficient, and sustainable access to the lunar surface for astronauts sent as part of the Artemis program. Additionally, it will serve as a research and science center in lunar orbit. This space station will have a modular design, constructed by assembling different modules including life support systems, laboratories, living quarters, and communication equipment. The primary purpose of Gateway is to alleviate the technical and logistical challenges involved in landing on the lunar surface and to prepare astronauts for longer duration missions. Moreover, it is planned to be utilized as a vehicle for human missions to Mars and other deep space destinations, serving as a preparation and logistics hub for missions to Mars. Gateway is an international collaboration project involving contributions from not only NASA but also other space agencies and commercial entities. The construction and operation of Gateway play a critical role in the sustainability of human presence in space and the future of deep space exploration. The equipment to be used in the Artemis program is of critical importance for the successful implementation of crewed lunar missions. The Orion spacecraft, developed by NASA for the Artemis program, is designed to support crewed space missions. It is equipped to transport, accommodate, and return the crew to Earth while in lunar orbit. It can be considered a modern version of the Apollo spacecraft used in the Apollo program and has the capacity to carry 4 astronauts. Designed for crewed space missions, it is equipped to support astronauts during long-duration space travel. The length of the spacecraft is approximately 3.3 meters, with a width of 5 meters. Its launch weight is approximately 25 tons, which may vary depending on the payload and fuel it carries during launch. Constructed from aluminum alloys, it possesses a robust structure designed to withstand various physical challenges encountered in space. Orion's power source consists of solar panels to provide energy during launch and space missions. It features a modular design, allowing customization for different missions. Orion is equipped with the necessary life support systems and a return capsule for long-duration space travel. The Space Launch System is NASA's most powerful and highest-capacity launch system developed for space exploration. Designed to enable the return of manned space exploration for the United States and facilitate deep space exploration, this rocket has sufficient power to transport manned vehicles and other payloads to lunar orbit. Serving as the primary launch vehicle for the Artemis program, it will carry crewed Orion capsules and other payloads into space. Its main components include the core stage, solid rocket boosters, and upper stage. The core stage, supported by high-performance RC-25 rocket engines, provides the primary thrust for the rocket. Its diameter is approximately 8.4 meters and includes fuel tanks and RC-25 engines. The weight varies depending on the components of the launch system and the payload. A fully loaded space launch system weighs approximately 2,600 tons. The solid rocket boosters, located below the core stage, provide additional thrust during launch. Depending on their length, the auxiliary stages of the space launch system can have varying diameters. When operating at full capacity, the rocket's thrust can reach approximately 39.1 meganewtons. The Artemis program will use specialized landing modules for lunar landings. These modules are equipped to transport the crew to the lunar surface and safely land them. They house the necessary life support systems and other equipment required for surface operations. To conduct scientific research and support exploration activities on the lunar surface, the Artemis program will utilize lunar rovers. These rovers are designed to explore the lunar surface, collect samples, and conduct scientific measurements. Built to withstand lunar surface conditions, they possess the durability required for long-term operations. The Artemis program plans to conduct various scientific research on the Moon. These research efforts aim to gain deeper insights into the Moon's geology, geophysics, resources, and evolution. The Moon, despite being Earth's closest neighbor, has a different geological history. The Artemis program aims to gain more knowledge about the formation and evolution of the Moon by examining its surface and underlying geological structure. The mineralogy and chemical composition of the lunar surface can provide clues about how the Moon formed and evolved. Artemis missions will attempt to understand the nature and origins of minerals and chemical compositions on the Moon by collecting and analyzing surface materials. Geophysical methods will be used to gain more information about the Moon's interior structure. Activities such as creating gravity maps, conducting magnetic field measurements, and monitoring seismic activity can provide a better understanding of the Moon's interior and formation processes. The Artemis program aims to discover and potentially utilize resources on the lunar surface. Water ice, regolith materials, and other resources may be processed or extracted for use in future manned space missions. By conducting various space environment studies on the lunar surface and in nearby orbit, it aims to understand the long-term impacts and safety of human presence in space. Among the long-term goals of the Artemis program are the establishment of sustainable human presence on the Moon and the expansion of deep space exploration. It aims to establish the necessary infrastructure for humans to live and work on the lunar surface, which may include habitats, life support systems, energy production and storage systems, water purification facilities, and other essential facilities. For long-term presence on the lunar surface, the production of food and other materials from local resources will be crucial. Therefore, the development and implementation of agriculture and production technologies in space could be significant goals. For a sustainable presence on the Moon, the development of energy production from sunlight and storage systems is also necessary. These systems should be designed to accommodate the Moon's day-night cycles. The Artemis program places great importance on international cooperation and partnership efforts. NASA collaborates with other space agencies, governments, and commercial partners for the successful implementation of Artemis. The Gateway Space Station, one of the central components of the program, is an international collaboration and partnership effort. The European Space Agency, the Japan Aerospace Exploration Agency, the Canadian Space Agency, and other countries' space agencies contribute to the Gateway project. Don't forget to subscribe for brand new documentaries and more scientific content.